this is working. Hopefully it is. If not, I don't really know what else I can do if it's not working. So we'll go ahead and get started here. I'm going to share my screen so you all can see the PowerPoint slides here. So I'm going to try and pretty much just do the same thing that that I've done in the past with the first exam with the review, where I'm just going to go through and I'm going to cover the high points, talk about the stuff that is really important, stuff that's not necessarily quite as important. Hopefully I don't lose my voice halfway through. I don't know, we'll see. But we'll make it as far as we can for sure. We'll get through the PowerPoint slides at least, and then we can do some practice problems and stuff if we want to do that. I can draw on the screen over here on my side to show you how to work through stuff. So let's go ahead and just jump into Chapter 13 here. So just to give you a broad overview of the entire exam really is just all about equilibriums. So we just have the first chapter here is, is my little pad here not going to work? Sorry, my writing pad is not responding. We are a super professional bunch here. I wonder if the battery in my pen is dead. Let me check that. There we go. Yep, the battery was dead. Okay. So, equilibriums. So that is really the topic of the entire exam. It's just equilibriums specifically in the case of acids and bases, and then equilibria in the terms of solubility. So those are kind of the big main topics. So here at the beginning, I'm just introducing the idea of equilibria. How we have two reactions, one going forward, one going reverse, and how at equilibrium they are they're reacting with equal rates. So you have the products being produced just as fast as the reactants are being produced, and so you can set the rates of those two things equal to each other to give yourself the equilibrium constant. So this process of working out the equilibrium constant expression, this products over reactants with the coefficients as exponents, I do expect you to be able to do that for any reaction that I give you, and that will be a question on the exam. That'll be kind of a nice easy question for you, at least it should be a nice easy question for you, where I just give you one or two reactions and just say, write the equilibrium expression. So just to remind you again, it's products over reactants. It would be helpful if I spelled it right. Reactants. With the coefficients as exponents. And kind of the one thing that generally is forgotten is that this is not going to include things like there we go, solids. So a solid is not going to show up in there, and neither is a pure liquid. So you're just going to have excuse me, things that are in aqueous phase and things that are in gas phase are really the only two things that are going to show up in that equilibrium expression. So you should be able to do that just for any reaction I happen to give you. I do expect you also just to have a general understanding of what is happening at equilibrium. And so that's kind of just the first few slides here, just kind of introducing you to equilibrium. So I expect you to know again that the two rates are equal, the forward and reverse rate, but that does not necessarily mean that the amount of stuff is equal. So at equilibrium, you don't have equal amounts of products and reactance necessarily. You could, theoretically, but that is not required. All that's required is that the two rates are equal, one direction or the other. As far as KP, I'm not going to give you anything over KP, so you don't. I know you had homework questions that did stuff with this, but it's not on the exam. Already talked about heterogeneous equilibria. Let's see. Alright, so now we're getting into solving equilibrium problems and using ICE tables. I definitely expect you to be able to use ICE tables. And if you remember, there were kind of two different variations on these kinds of questions. There was this variation, where I give you some information about an equilibrium concentration, along with initial concentrations. And so, given that information, you can work out what the changes are, and you can work out what the concentrations would be at equilibrium. Excuse me. So that's one version of these equilibrium problems. So again, this version, I have to give you something about at least one of the equilibrium concentrations. So in that case, there's no unknowns anywhere. There's no need for an unknown x. You are just using the information that I give you to work out what the changes must be, given the balanced chemical equation, and you can work out, I think in this case we're finding Kc. Yeah, so we're finding Kc there. Or maybe you're trying to find the equilibrium concentration of something else. I expect you to be able to do questions like that, where I give you one equilibrium concentration and initial concentrations, and you have to work out the rest of the table. The other kind of question is where I don't give you an equilibrium value, and you have to do this whole process here. So there's that whole thing there. Let me go back to the beginning of that. So there's this whole process where I still give you the initial values, so you still know where you're starting, but instead of giving you an equilibrium concentration, I give you the equilibrium constant. And so then, in that case, you do have to use the x values. So again, you don't know exactly what the changes are, but you know relatively how things are changing. And so you can use that and solve for x to get the information you need to solve that problem. Alright, and as far as the x is small assumption, and I know someone just asked a question, I'll get to that in just a second. As far as the x is small assumption, which is what this part here is talking about, simplifying the math with the x is small assumption, the way I always do these exams is you can use the x is small assumption unless I specifically tell you that you can't. So if in the question I say, do not use the x is small assumption, then obviously don't use it. If I don't mention it, if I just give you a question, and it would make the question easier to use the x is small assumption, you are safe to assume that you can use it. I'm not going to have you checking your work to see if the x is small assumption is viable or not. Unless I specifically tell you otherwise, you can use it. If you want to not use it and you want to go ahead and do the quadratic equation, more power to you. More math never hurt anybody, but you don't have to unless I specifically say you cannot use the x is small assumption. Alright, let me see what that question was real quick. Can you use the math solver? Yes, you can. Yeah. When I send in the exam to the testing centers, one of the boxes that I fill in is telling them what kind of calculator you can use, because some professors don't let students use graphing calculators, and I allow you to do that. So you can use the math solver if you want to, if you're comfortable with that. It might be difficult to do that on here, but we can try that later. After we get through the slides, I can try to show you how to do that. All right. So I believe, yeah. So pretty much the rest of this chapter here is over Le Chatelier's principle. I definitely expect you to both understand and be able to solve questions concerning Le Chatelier's principle. So I could give you several different situations and say, I make this change, or I add this material, or I increase the pressure. And I expect you to be able to tell me, based on those things that are happening, which direction the equilibrium is going to shift, either to the left or to the right. And kind of in the same vein, I expect you to be able to kind of do the opposite, where perhaps I would say, hey, here's this reaction. I want to make as much of this product as possible. What could I do to shift the equilibrium to the product side? You know, I can name as many things as you can think of that I could shift the reaction to that side. So it's kind of just the same question, but two different ways of asking it. So there is a question over Le Chatelier's principle on the exam. So make sure that you know how to look at an equilibrium and analyze the effect that will happen when different changes are introduced to the system. And then there's one little thing here at the end here. So as far as catalysts, I do expect you to know that catalysts do not have an effect on equilibria, other than just getting them to the equilibrium faster. So they get you to the equilibrium quicker, but they don't actually have an effect on it other than that. And that's all I expect you to know from for catalysts. All right. So chapter 14 is ginormous. So chapter 14, acid-base equilibria. We'll try to get this through this as quick as we can. So here at the beginning, we're looking at some different definitions of acids and bases, Arrhenius acids and bases, Bronsted-Lowry acids and bases. I do expect you to know the definition of the Bronsted-Lowry acid and base. The other two I do not expect you to have memorized. But I do expect you to know the Bronsted-Lowry definition. It's pretty straightforward. It's just an acid is a proton donor, a base is a proton acceptor. So that could be a nice, easy true-false or multiple choice question. I also expect you to be able to work out what the conjugate acid or conjugate base is of an acid or base. So I could give you a question where maybe I say, here's a base, a weak base. What's the conjugate acid? And so you would have to work out what the conjugate acid is. I could also do something kind of similar to this one, where maybe I give you an equation and I have you label, this is the base, this is the acid, this is the conjugate acid, this is the conjugate base. So the main gist there is just be able to identify what's acting as an acid, what's acting as a base, and what they turn into after they act as an acid or base. Because again, you're just adding or taking away H pluses. Alright, as far as strong versus weak acids, I do expect you to just generally understand the difference between the two. So a strong acid is completely dissociated in water, whereas a weak one only partially dissociates. And more specifically, I do expect you to know I know they're back here a ways, but we'll go back to that in a second. But I do expect you to know the 7 strong acids and the 6 strong bases. So you should be able to recognize those if I give them to you. The strong acids are usually the ones that students have a harder time remembering. But I could give you a question on the exam and be like, you have HCl, and it has this concentration, what's the pH? So I would expect you to know that that's a strong acid, so all of it is going to dissociate. I don't need to do anything with equilibria with that. Alright, going back here. Okay, so there were strong acid, strong base stuff. We talked about that. So this is getting into equilibria with weak acids and weak bases. In case you were not aware yet, I am giving you a cheat sheet for acid-base equations. Just go ahead and show you that now, if you haven't seen it yet. That is this one. This is kind of a crummy scan of it, but so this is minding your P's and K's. And so it does have the equations for going in between H plus concentration and OH minus concentration, between pH and POH. Like it gives you the equations for all of those, as well as the equations for converting between Ka, Kb, and the pKa and the pKb. So this is, in addition to the periodic table and the normal conversions stuff, this is the only handout on the exam. Let's go back here. Alright, so now we're getting into the pH. I do expect you to be able to calculate the pH of a solution, especially if I just give you an H plus concentration or an OH minus concentration. That should be pretty straightforward. What's a little bit more difficult is if I give you a weak acid and say, here's the concentration of the weak acid, find the pH. But I do expect you to be able to do that as well. So through here, talking about measuring pH and the different indicators, like I'm not going to test you over that stuff. That was more just informing you about the ways of investigating acids and bases. Alright, so this is where we're getting into the meat here of finding the pH of weak acid solutions. I definitely expect you to be able to do this. There will be a question on the exam where you're just going to be finding the pH of a weak acid solution. It should be relatively straightforward. You should have done a bunch of these on the homework. I know we did multiple of them here in the slides. I will just give you something with the concentration of some weak acid, and I will give you the Ka for that, and you will need to find the pH. This specific problem here is kind of doing the opposite, where I give you the pH and you find the Ka. You should be able to do that as well. It's just kind of, it's the same overall process, you're just looking for a different thing, essentially. Kind of similar to how in the previous chapter we had some questions would give you Kc and have you find concentrations, and then other ones would give you concentrations and have you find Kc. It's the same idea. So that's those here, and then this is again kind of the same idea. Now we have the K value instead of an equilibrium value, and so we have to use unknowns to be able to find that. So you should be able to do those because there will be at least one question on the exam where you'll be finding the pH of a weak acid solution. As far as mixtures, I'm not going to give you a question where there's a mixture of two different acids. So I wouldn't give you something like this, where you have HF and you have HClO. It's not on there. There's not a question like that. Polyprotic acids are kind of the same way. We had homework questions over those. They are important to a degree, but they're also really time-consuming. They take a long time to solve, and I don't want you to spend 20 minutes on one problem, or even 15 minutes on one problem. So there is not a polyprotic acid question on the exam. There could be a weak base question. The weak base is very much the same as the weak acid, just, again, looking at it a different way. Since you have a weak base that's producing OH minus instead of a weak acid producing H plus. So that is definitely a possibility, so know how to find the pH of a weak base solution. As far as the relationship between Ka and Kb, like I said, I'm giving you that handout that has that in there. So you don't have to have that memorized, but you do need to know how to use it. Alright, so this is just kind of generally talking about acid strength and what makes an acid stronger or weaker. I'm not going to test you over that stuff. Something that I hope you know, but there's no questions over that on the exam. Lewis acids and bases, again, I don't have any questions over Lewis acids and bases on the exam. Hopefully you remember it and you're kind of comfortable with it. If you need to take organic chemistry, you're going to be learning all about Lewis acids and bases. And acid rain, I'm not going to test you over that. Any questions over those? Nope. Okay. Works for me. So then the last group of slides here, so we're just continuing on in chapter 14. So the common ion effect, I'm not going to have a question that's like specifically over the common ion effect because it's really leading into the discussion of buffers. And buffers will be on the exam. So make sure that you are comfortable finding the pH of a buffer, comfortable mainly using, where is it? Oop, there it is, yeah. Mainly comfortable using this equation. You will need to use that equation on the exam, and that equation is not given to you on the exam. So you do have to have the Henderson-Hasselbalch memorized. Thankfully, it's not a super complicated equation. You can remember it, and the way I always do that is when I was a student, if there was an equation I was worried about remembering, I would be sure that I could remember it right at the very beginning of the exam, write it on the first page of the exam, and then have it there to reference, just in case, later. But I believe this is the only equation that I don't give you that you need. Because all the other ones are on that minding your P's and K's sheet. But this one is not. But you do need it. Because, like I said, there is at least one question about buffers on the exam. So make sure you are comfortable solving questions covering the concept of buffers, and you are comfortable using this equation. Alright, this is just more about buffers and doing calculations with buffers, which then leads us into the discussion. Oh, and this stuff in here about like buffer capacity, pH range. There's not going to be questions about that. So look, I'm not going to give you like, here's two different buffers, which one works better. Like there's not a question like that. I could ask you a question kind of similar to this one, where it's just, you know, you're trying to make a buffer at this pH, which one of these acids would work best. But it would not be one like this, where you would have to like analyze concentrations and like here, we had a lot of stuff on this slide. Like it's much too much for a question on an exam. But this is much simpler and straightforward, so there could be something like this on the exam. Alright, so that leads into titrations, everybody's favorite topic. The main gist of titrations is I expect you to be able to find the pH of a titration at any point in the titration. Now, that being said, I will not ask you to find the pH of a titration at every point in the titration. Like, I'm not going to have a question where you're finding the pH at 4 different points in the titration. I wish I could do that. I wish I had like 3 hours to give you a test, although I'm sure you would hate that. But we just don't have time for that. Like, it just take way too long. So instead, there is a question on the exam, and it will ask you to find the pH of a titration at 1 point in a titration. So it won't be multiple points. Like I won't ask you to find the pH initially, before the endpoint, at the endpoint, past the endpoint. Like I won't ask you to find all of those. I will ask you to find just one of those. So make sure you know the process for finding the pH at all 4 of those, so that when you see the question, you can say, oh, well, that is after the titration has started, but before we reach the endpoint, so I'm going to solve this like a buffer, which is what it was talking about here. So before the equivalence point or endpoint, depending on how you ask, we treat the solution like it is a buffer, because it actually is. It's essentially a buffer at that point. And so you would solve it using the Henderson-Hasselbalch. If I asked you to find the pH directly at the equivalence point, you would treat it like a weak base, because it's going to be a weak acid titration. I'll just tell you now. I'm not going to pull a fast one and be like, it's a weak base titration. No, it's a weak acid titration is what it's going to be. So it's going to be weak acid with a strong base. And so I could ask you to find the pH at the equivalence point, and so in that situation you would treat it like a weak base. So again, there's essentially 4 different regions, and you treat the titration differently in each one. There's the initial, where it's just a weak acid, kind of in the middle, once it's started but before you reach the endpoint, you treat it like a buffer. At the endpoint, you treat it like a weak base. So you calculate it like a weak base equilibrium. And then if you go past that, you would just treat it like a strong base. So again, I will not ask you to find the pH at all 4 of those. I believe you did a homework question where you did have to find the pH at all 4 of those. I'm just going to ask you for one of those 4. All right. I'm not going to have you drawing titration curves. but I could have you analyzing one. So I could give you, for example, something like maybe like this, and just maybe like have you label different regions. So like I could have the point here and have something for you to label that. Say that's the equivalence point or the end point. This would be the buffer region. So I could have you do that because you should know the general regions of the titration curve. And that's really pretty much it in terms of the region. It's just you have the starting point, buffer region, and the end point. It's really the only regions there are. Alright, so this is just a bunch of stuff about indicators, following titrations, and not too worried about that. Alright, so then the last bit here is solubility equilibria. And it's pretty self-explanatory. It's pretty much just the same as the first chapter in that, you know, I expect you to be able to write the solubility product. So, you know, if I give you something like this, you should be able to write KSP for that. And it is literally just exactly the same as any other K value, so it's not like there's anything special about it. It's just, in this case, it would be KA, or CA, 2 plus, and F minus to the second, because we have 2 of those. So just being able to write the KSP expression, and then being able to solve either for KSP if I give you equilibrium concentrations, or be able to solve for the equilibrium concentrations if I give you KSP. Again, it's the exact same mathematical ideas and processes as the previous chapters, just now being applied to solubility processes instead of acids and bases. Alright. And there will be at least one question on the exam where I will either have you find KSP or find an equilibrium concentration, one or the other. But there is at least one question where I have you do that, so make sure you are comfortable working with KSP. This stuff here at the end about the factors that affect solubility, really all I expect you to know here is just generally that the pH can affect solubility, that complex ions can affect solubility. Not really anything beyond that. I'm not going to have like specific questions over, you know, this specific ion here, how is it affected when you add this? Like, nothing like that. Just generally knowing that you can affect the solubility by putting other things into the solution. And so that would be adjusting the pH, because that would be adding an acid or base, or adding some other ion that can create a complex with it. And this selective precipitation thing, I'm not going to ask you anything for that. That's something that sometimes you'll do really cool labs with those, but we're not going to do anything with that over in the exam. All right. Questions?
I have a question. Are you still gonna do that calculator thing, or did I miss it?
You did not miss this, no. Let me see if I can figure out a good way to do this. 90 minutes. You will have 90 minutes for the exam. Excuse me. Alright. I'm gonna try. math solver works for any calculator that has it. As far as I'm aware, the only calculators that have the math solver are graphing calculators. But I believe you can borrow graphing calculators from the library if you don't have one. So if you wanted to do that, what I would suggest is like a day or two before you take the exam, go to the library, ask to rent a calculator. I'm not sure if they let you take it off campus or not. They probably don't. But even if they don't let you take it off campus, you could rent a calculator, go and get comfortable with it before the exam. Make sure you know how to use the solver function and everything. And then on the day that you take it, you can go and borrow it again and be comfortable with it and be ready to do stuff with that. Okay. I'm going to try... so the last problem on the practice exam. I probably can here in just a minute. Let me see if this will work. Well, maybe not. Trying to figure out a way. Just see what happens if I do this. Yeah, that's not working. I wonder, can I pull it from a different place? I'm gonna try something real fast. Yeah, the alternative would be to use the quadratic equation. I'm gonna sign out real quick and then hop back on because I didn't have my webcam plugged in when I signed in to collaborate, so it might not realize that it's there. So I'm gonna sign out and sign back in real quick. Alright, I'm back. And it's still not working. Okay. I don't know why my webcam is not working. It's not working for some reason. Let me try and just descriptively tell you how to use the solver function. And let me find a good question. Good question to show you what to do with it. Okay, that should work. Alright, let me share my screen again. Alright. So, this is a way more intense equation than what I would give you on an exam. But let's say, for example, we wanted to solve this equation here. So we're not making the x is small assumption. Everything we have in there is what we would be solving for. We'd be solving for x. So on your TI calculators, at least, because that's the only one that I'm familiar with, what you would do is you would click the math button. So it should be a button kind of in the top left corner, but not quite all the way to the top. There's a button that's called math. If you hit that, it takes you to a new page. You then hit up, so hit the up arrow, and what that will do is it'll take you to the bottom of that list, and it should be solver. Some of the newer ones, I think, say math solver or something like that, but mine just says solver. So if you click on that, on the older versions, you'll see something that says equation solver, and it says EQN 0 equals, and then just blank. Like there's a spot where you can type stuff in. The newer models are a little bit different. Instead of having the equation is equal to 0 is equal to something, they have two different boxes. And so you would put one side of the equation in one of the boxes and then the other side of the equation into the other box to get it to solve. But most people have the older either 84s or 83 pluses, and so those will look like this. You'll just have the equation is equal to, or equation is 0 equals something. And so your goal is to put the equation in here, this blank area. So if I were to plug this in, for example, how I would plug that in is I would start with the numerator on the right side of the equation, and I would type it in as 4, let's see, and actually I would have open parentheses, and I would actually probably have two open parentheses, because I would have one parentheses for the entire fraction, and then I would have another set of parentheses for just the numerator of that fraction. So I would have 4, and then I would pick a letter. And the letters are the green buttons, so the alphanumerics. So there's a green alpha button on the calculator, so you're going to hit that, and then just pick a letter, any letter. It doesn't actually matter, or at least it shouldn't matter. So let's say you pick N. Why not? So you do the green button, the alpha button, and then N. On my calculator, that is the log button, would give you N. So we have 4 N, and then I would raise that to the third. And so depending on your calculator, some calculators have a button where you can just put in 3 raised to the third. Other ones you would have to do the caret 3. So it just depends on your calculator. But you would have 4 N raised to the third. I would close the bracket to keep everything in the numerator together. And then I would have divided by open parentheses 0.025 minus 2n, because again we're using n for x here, close parentheses, squared, close parentheses. So all I did there was just input this fraction into the calculator as best I could, making sure that I was keeping stuff together that's supposed to stay together. So just because I'm running out of space here, you wouldn't actually move to another line here, you would just keep going, but since I'm running out of space there, the next thing I would type in would be minus 1.67 e minus 7. So that would be this side of the equation. And it's minus that because, remember, we're having to set this equal to 0. So we're saying 0 is equal to our entire equation. So to get 0 over here, we have to subtract 1.67 times 10 to the negative 7 from both sides. So that ends up moving it over to the other side. and I'm using the E there. That's the engineering exponent. So that's the second button, and then the EE, that's the comma is what that's on mine. So I know the button says EE, but in the calculator it's just a single E. And so that represents times 10 to the negative 7. Okay, so I'm going to go ahead and actually type it into my calculator now, because I haven't been doing that as I've been going along here, just to make sure that it gives me the correct answer. N squared minus 1.67 times 10 to the negative 7. Okay, so I have that typed in. Once you get it typed in, you're going to hit enter. And that should drop you down to a spot where it shows your variable. And it says n, and since we used n in this case, it says n is equal to 0. It's not saying that n is actually equal to 0. That's just telling you it hasn't done anything yet. So it hasn't actually performed the calculation. So what you're going to do is you're going to hit the alpha button again, and then you're going to hit enter. And the alpha option on enter is solve. And so what it's telling me is 2.9196 blah 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 blah. So it gives me a lot of stuff. When it does that, make sure that you scroll all the way to the end, because it hides the scientific notation at the end of the answer. So this is 2.9196 times 10 to the negative 4, which matches up pretty nicely with what they got for x here. You notice how it's a little bit off, and that's because we didn't make the assumption. So our answer is actually better than this, but they're still really close. They're close together. All right, so a couple quick things. If you get an answer that doesn't make any sense, so this answer makes sense. It's very close to what the question got as their answer. But if I got something that was really wonky, one of the easiest things you can do to see if it's just something weird happening with your calculator is just replace the letter. So instead of using N, maybe use like O. Just like plug O in there, or P or R or W or just any other letter. Just pick a different letter, stick it in, and see if it gives you a different number. Sometimes, I don't know why, I honestly have no idea what's going on, but sometimes the calculator just gets it in its head that that letter is equal to a number and not a variable. So if you get a number that doesn't really seem right, just go back and plug in a different letter and see if it gives you a different number as a result. If it doesn't give you a different number, then that's actually a pretty good indication that the number you have is correct. Okay, let's see. I thought I heard comments coming in, but I guess there was something else. Are there any questions about using the solver?
I have a question. So what happens if you have two boxes, like you were talking about?
So if you have two boxes, you don't have to mess with setting it equal to 0. So you could just plug the two different sides in.
So would I just do the first part, like the 4 and 3, blah blah blah, and then on the bottom one it'd be equal to 1.67?
Yes. Yes.
Okay.
So you would do everything exactly the same way that I did there. You just wouldn't have to have the negative 1.67 times 10 to the negative 7 at the end. You could just put 1.67 times 10 to the negative 7 in the other box. So
does it matter which box?
no, it doesn't matter.
Okay.
So one side would go in one box, the other side goes in the other box.
Okay, thank you.
No problem. Other questions about solver function? No? Okay, somebody asked to do the last question on the example exam. Let me pull that up. Okay, so it's the buffer question. So this question says you have a buffer composed of a half a mole of... Alright, to click that or it wouldn't let me write on here. Half a mole of HF, half a mole of NaF dissolved in 1 liter of solution. What is the initial pH of this buffer, and then what is the pH of the buffer after a certain amount of HCl has been added? And then I give you the Ka. And by the way, in this exam as well, I think in this example exam I do the same thing, but in the exam that you'll be taking at the testing center, I just give you all the Ka values. I don't make you look them up on a table. They're in the question. Save you, a couple minutes worth of time. So this one we have 2 parts. So in both of these situations we're going to be using the Henderson-Hasselbalch because we have a buffer, and in both situations we're trying to find the pH. So if you remember the Henderson-Hasselbalch, oh wait, is it plus or minus? I always second guess myself on whether it's plus or minus the log of the base over the acid. It is plus. Okay. Shouldn't have second guessed myself. Plus the log of the base over the acid. Okay. Plus the log of the base over the acid. So this equation would be used for both part A and part B. So really all that you're doing is, first of all, you would have to find the pKa, and that's relatively straightforward because I give you the Ka. So it would just be the negative log of 3.5 times 10 to the negative 4, which will end up being, I don't know, 3 something maybe, something like that. And then the base and the acid, really all you have to do is just plug in the number of moles. So you would just take half a mole of the acid, which is the HF, plug that in there, half a mole of the NaF, which is your base, plug that in there, and you would solve for the pH. And what you'll find in this case is, because you have equal amounts of acid and base, this here just goes away, essentially. It becomes 0. Because the log of 1 is 0. So you're just going to end up with the pH is equal to the pKa for part A. For part B, it's a little bit more complicated, but really not a lot more complicated. So you already have the pKa, because again, we're still using the Henderson-Hasselbalch. So we're still using this. And we already have the pKa, but now we don't have equal amounts of acid and base because we added in a little bit of acid. So we added in 0.119 moles of acid. And so what that means is that our base value is going to decrease by that amount. And our acid is going to increase by that amount. Because when we add that acid into the mixture, it's going to react with the strongest base that it can find, which will be our weak base, and it'll use that up. It'll use up the same amount of that weak base, and as a result of reacting with the weak base, it's going to be converted into the weak acid. So essentially we'll end up with 0.619 of the acid. Actually, sorry, got that in the wrong spot. So we'd have 0.619 of the acid, and then, let's see, I don't know if I'm brave enough to do that in my head. 0.381 of the base, if I'm doing that right. Did that in my head. Let me do it on the calculator. So that'd be 0.5 minus 0.119. Oops. There we go. 0.5 minus 0.119. Hey, I did it right. So that would just be your new base and new acid values, and so you just plug those in. You already know the pKa, and that would give you the pH. Does that answer your question? I forget who asked that initially. And the chat from before is gone. I didn't realize it deleted the old chat when I logged out and logged back in.
Are you going to post the exam answers or the sample exam answers?
Yes, I'm going to try and do that today. I don't have the best scanner here at my house, but I'll try and get that done today. What other questions? Nothing else? Would you be able to give us an example on the titration? Sure. Let's see. Let's say we have a weak acid, and we have 0.3 moles in 1 liter. And the Ka for that weak acid is 1.76 times 10 to the negative 4. I think that's the Ka of acetic acid, but I'm not sure. So this is our starting point. We have a weak acid, we have this much of it in 1 liter of solution, and I want to know what is the pH after after adding 20 mils 2 molar HCl. Sorry, I'm kind of slow. It's trying to make sure that the question ends up being the way I want it to be. All right. So we've started titrating our weak acid here. So we know for sure that we're not at the starting point, because if you remember, there were 4 different regions. There was the start, there was midway through the titration, there was at the end point, and there was past the end point. So those were kind of our 4 regions of the titration, and we would treat the titration differently depending on where it was. So we know that we aren't at the starting point, because we've already added some, oh, I said HCl, that shouldn't be HCl, sorry, sodium hydroxide. So we've already added some strong base. So we know we're past the start point. So we need to figure out, have we gotten to the end point yet? So to do that, we just have to figure out how much acid we start with, how much base did we add in. And so the easiest way to do that is just using the molarity equation. Now, the way I wrote the question, we already know how many moles of acid we started with, so we don't have to worry about that. But for the base, we do have to figure out how many moles we've added. If you remember, the molarity is the moles divided by the number of liters. So, to figure out how many moles we have added, we would need to take the molarity and multiply it by the liters. So we're just doing some basic algebra, rearranging that to figure out how many moles we have. So if we do that with our numbers here, 20 mils is 0.02 liters, which, again, I did that in my head. You can, if you were in the exam, it'd probably be a good idea to look up the numbers, but just for the sake of time here, I'm just doing that in my head. So that is 0.02 liters. And we're going to multiply that by the molarity, which is 0.2. And so that would be, this is a smaller number than I wanted it to be, 0.004 moles. Tell you what, I'm going to make a slight change here. Just because that's such a tiny amount, it's not really going to have an effect on the number of moles. This is why I don't really like making up questions on the fly, because the numbers don't work out correctly. So I'm going to make a slight change here. I'm going to say it's not 0.2. It is 1.2. Let's see what that gives us. So if we have 1.2 instead of 0.2. Okay, that's better. Still kind of low, but I think it'll work. So now instead of 0.004, we have 0.024 moles of base that we have added so far. All right. So now the question is, have we gone past the end point yet? Are we to the end point? And the answer to that is no. We're nowhere near. We're nowhere near the end point. Because remember, the end point, or the equivalence point, I misspelled equivalence there, but oh well. So the equivalence point is where you have the same amount of acid and base. And we're nowhere near the same amount. We got a long ways to go before we get there. but we are somewhere in the middle. We're somewhere in the middle of the titration. And so because we know we're in here, we know that we're going to be using the Henderson-Hasselbalch. So what we need to do is just plug in everything we know. So we know that the pH is equal to the pKa plus the log of the base over the acid. We're given the Ka, so the pKa would just be the negative log of 1.76 times 10 to the negative 4, which I believe is 4.76, but I'm going to check. Oh, I'm glad I checked. I was wrong. So that is 3.75. So that's my pKa. So then I would add to that the log of the base, which is 0.24, over the acid, which is going to be 0.3 minus 0.24. Because we started with 0.3 of our acid, but a little bit of that is consumed by adding in that that acid, or that base, sorry. So it would be 0.3 minus the 0.024, which you could do that math before you put it in there as well. That would work just as fine. So if I do that math, I get the pH is 2.69. Did I do that right? Yeah, looks like I did it right. Okay. That number just doesn't seem right to me, but I don't see any mistake that I made, so if anyone can see a mistake I made, please point it out. But it seems like that number should be higher than that. That might be a result of not having enough of the acid present. Yeah. So the math and everything there is correct. This isn't necessarily the best example just because we really should have more of that base present. Like, for a buffer to really be a buffer, you need not equal amounts of acid and base, but at least significant amounts of both, and we don't really have a significant amount of that acid there. But in terms of actually solving the problem, that's how I would expect you to solve it. So you just work out, where am I in the titration? Alright, I know that I'm here. I need to use the Henderson-Hasselbalch. What do I have? Like, what acid, what amount of acid and base do I have? Plug those in and solve for the pH. Any questions about that? None? Alright. Any questions about anything else? there are no other questions, at least for now, I will let you all go. As always, feel free to email me with questions if you have any. And I'll get back to those as quickly as I can. Like I mentioned, I'll have that key up hopefully today. I don't think I'll have any trouble getting it up today, so I'll just be watching for that. And I'll talk to you all later, and good luck on the exam.